Imagine standing next to a machine so large you can't see where it ends, not because of distance, but because your brain literally refuses to process the scale. Machines that outweigh skyscrapers, that move more Earth in a day than entire cities did in centuries, that are so massive they reshape the planet just by doing their job. These are not vehicles. They are not tools. They are industrial ecosystems. And today, we're looking at the biggest machines humanity has ever built, and what it actually takes to make something this impossible real. Bagger 293, the largest land vehicle on Earth. In the Rhineland region of Western Germany, there is a coal mine so vast it swallowed entire villages. Roads were rerouted, rivers were redirected, and the machine that made all of it possible is something most people will never see in person, but would never forget if they did. The Bagger 293 is the largest land vehicle ever built by Massachusetts. Manufactured by the German engineering firm ThyssenKrupp in 1995 for the Hambach open-pit mine, it stretches 740 feet from end to end, longer than 2 American football fields placed back to back. It weighs 14,200 metric tons. For comparison, the Eiffel Tower weighs roughly 7,300 metric tons. The Bagger 293 outweighs it nearly 2 to 1. At its core is a rotating excavation well 70 feet in diameter, rimmed with 18 steel buckets. Each bucket tears 530 cubic feet of earth from the ground in a single pass. Operating continuously, the machine excavates 240,000 cubic meters of material every single day, enough to fill 96 Olympic swimming pools before sunset. It moves on crawler tracks so wide they resemble a city avenue. And yet, despite its incomprehensible size, it takes a crew of only 5 people to operate. The trade-off for that simplicity: turning around takes 20 minutes. The Bagger 293 doesn't work in a mine. It is the mine. It doesn't dig through geography, it rewrites it. Bertha, the tunnel boring machine that broke down and came back. There is something quietly unsettling about tunnel boring machines. They are sealed metal cylinders, working in total darkness, grinding through solid earth, assembling tunnel walls behind themselves as they go. They never see daylight until the job is done. Bertha was one of the most ambitious TBMs ever attempted. Named after Bertha Knight Landis, Seattle's first female mayor, she was manufactured by Japan's Hitachi Zosen Corporation and measured 57.5 feet in diameter. At the time of her construction, the largest TBM on Earth. She was assembled underground in Seattle in 2013, commissioned to bore the tunnel that would replace the structurally compromised Alaskan Way viaduct along the city's waterfront. Almost immediately, the project became a lesson in how quickly billion-dollar machines can be humbled. Less than 1,000 feet into a journey of nearly 2 miles, Bertha struck a steel pipe, left in the ground from a previous survey decades earlier, and overheated. Her cutting head seized. She stopped. Recovery required digging a rescue pit 120 feet straight down through Seattle's urban core. The delay stretched into years. Cost overruns climbed into the hundreds of millions of dollars. She finally broke through to the other side in 2017. And then, as with nearly all TBMs, she was disassembled underground. There is no practical way to recover a machine this size intact once the tunnel is complete. Her cutting head alone weighed more than 2,000 tons. She did the job. She just did it on her own terms. Caterpillar's 6090 FS. 1 scoop, 1 truck. In open-pit mining, time is money measured in tons per hour. Every cycle, dig, swing, load, return, has to be as fast and as full as possible. The Caterpillar 6090 FS was engineered to win that equation at a scale that makes conventional excavators look like garden tools. Originally developed by ONK, refined by Terex, and eventually absorbed into Caterpillar's lineup, the 6090 FS weighs over 1,000 metric tons when fully configured. Its bucket holds between 52 and 70 cubic meters of material, enough to fill a standard mining dump truck in a single pass. 1 scoop. Truck loaded. Next, what separates it from older rope shovels is its hydraulic drive system. Where cables and drums offer raw power but imprecise control, hydraulic pressure gives operators fine command over every movement. The result, a complete dig-and-swing cycle in under 30 seconds, hour after hour, day after day. These machines work in some of the most punishing conditions on the planet. Copper mines in Chile's Atacama Desert, where the heat is brutal and the dust is constant. Iron ore operations in Australia's Pilbara region. Coal mines in Wyoming's Powder River Basin, where temperatures swing from scorching summer heat to Arctic winter cold. And the machine simply keeps working. Big Bud 747, the greatest farm tractor ever built. Most of the machines on this list live in mines or construction sites, invisible to ordinary life. Big Bud is different. It works on a farm. Built in 1977 by the Northern Manufacturing Company in Havre, Montana, the Big Bud 747 was commissioned by a California farming operation that needed to work land so flat, so vast, so relentlessly agricultural that it demanded a tractor unlike anything that existed. So they had one custom built. It weighs 100,000 pounds. It stands 14 feet tall. Its tires are 8 feet in diameter. Its original Detroit diesel engine produced 900 horsepower, later upgraded to 1,100. Its fuel tank holds 1,000 gallons. Because a machine this large cannot afford to stop, Big Bud can pull planting implements 24 rows wide in a single pass. On flat American farmland measured in sections rather than acres, that is not overkill. It is efficiency. After years of changing hands and a long period in storage, it was purchased and restored by brothers Robert and Randy Williams of Montana, who still use it on their farm today. Big Bud didn't retire. It went back to work. NASA Crawler Transporter, the slowest critical machine in history. The Saturn V rocket that carried human beings to the moon stood 363 feet tall, weighed 6.2 million pounds fully fueled, and represented the most complex machine ever assembled. Before it could fly, someone had to move it. NASA's answer was the Crawler Transporter, and it is, in its own way, just as extraordinary as the rockets it carries. Built in the mid-1960s by the Marion Power Shovel Company, the two Crawler transporters at Kennedy Space Center each weigh approximately 2,700 metric tons unloaded. They travel at a maximum speed of 2 miles per hour on open ground, dropping to 1 mile per hour when carrying a fully loaded rocket stack. Each of the 4 crawler tracks is made of individual steel links, each link weighing 1 metric ton. The platform on top is kept perfectly level by a hydraulic compensation system accurate to within 1 degree of tilt. A Saturn V or space shuttle cannot be tilted beyond that threshold during transport without risking catastrophic structural damage. The 3.5-mile journey from the vehicle assembly building to the launch pad takes approximately 5 hours each way. The machine burns 150 gallons of diesel fuel per mile traveled. They have carried every American crewed rocket since Apollo. After upgrades completed in recent years, they now support NASA's Space Launch System, the most powerful rocket ever built. The crawlers have not aged out. They have evolved. Prelude FLNG, a floating city that processes gas at sea. There is a structure floating off the northwest coast of Australia that is, by several measures, the largest floating object ever built by human hands. It is not an aircraft carrier. It is not a cruise ship. It is a gas processing plant. The Prelude FLNG, floating liquefied natural gas facility, was constructed by Samsung Heavy Industries in South Korea for Royal Dutch Shell and completed in 2013. It measures 1,601 feet long and 243 feet wide. When fully loaded with ballast, it displaces 600,000 metric tons, 6 times the displacement of the largest nuclear aircraft carrier on Earth. Its purpose is to extract natural gas from wells on the seafloor, pipe it up to the facility, cool it to minus 162 degrees Celsius until it liquefies, store it in enormous onboard tanks, and transfer it to LNG tankers that pull alongside to receive cargo. The Prelude can produce 3.6 million tons of liquefied natural gas per year without ever coming to shore. It is moored by a turret system that allows the entire structure to weather vane around a single anchoring point, always rotating to present its bow toward the worst incoming weather. This is not a convenience feature. The Prelude was designed to survive the cyclones that regularly sweep through that region of the Indian Ocean. It is not a ship that processes gas. It is a gas plant that floats. Every machine on this list was built because the job required it, not because engineers wanted to see how large they could go, not as a statement of national pride or corporate ambition, though those things played their part. These machines exist because somewhere in the world, there was a problem that no smaller solution could solve. A coal seam buried under 200 feet of earth. A tunnel through a city's bedrock. Gas fields accessible only by ocean. Farmland so vast it demands a tractor that barely fits on a road. The machines followed the need. And the fact that they ended up being the largest land vehicles, the widest excavators, the heaviest floating structures in human history. That is what happens when you stop asking whether something is possible and start asking how. Subscribe for more on the machines, megastructures, and engineering systems that shape the world most people never think about.